Welcome to episode 127 of 𝗟𝗡𝗡𝗆cast. I am your host, Connor, and today with us we have two panelists. I guess we can actually call that a panel. I've got Adam and Rich with us, so we're going to go around and do brief introductions, and after that we'll have a couple announcements, maybe just one. So we'll start with Adam, and then we'll go to Rich.
Right, I'm Adam 𝗔𝗿𝗆𝗆, and I do lots of APL things at Dialog Limited, where they gave me the title Head of Language Design too.
I'm Rich Park. I also do some APL things, including training and media at Dialog Limited.
And as mentioned before, my name's Connor, host of 𝗟𝗡𝗆cast, massive fan of all the array languages, and I think that's it for introduction. So I believe we've got just the one announcement, and we'll go over to Rich for that.
Yeah, so this spring we hosted the Dialog North America user meeting in New York, and recently we've been releasing recordings of the presentations from that conference. So if you go to the Dialog user meeting YouTube channel, I'm sure we'll put links in the appropriate places. You can watch presentations from myself and a couple of other Dialog people, and some users as well.
Awesome. Yeah, I've seen a couple of those. I know I've bookmarked at least one of them. I think it was by Asher, but I could be wrong about that. I think he gave a talk on the latest and greatest things in Dialog APL. Probably
yeah, he
most.
Did a couple.
Did he give a couple talks?
He did one that was sort of APL primitive developments this century, and then leading up to the enhancements in Dialog version 20, which does include more than just primitives. But
yeah. I can't remember which one.
That's a nice segue.
I've got them in a Google Doc. I love the feature in Google Doc where you paste a link, and then half a second later the YouTube icon with the name of the video replaces that link if you hit tab. Anyways, we will link those two talks, plus any of the other Dyna talks that have come out if you weren't in New York for that meeting. And you can watch them on your own time, leave comments, get your questions answered. And with that announcement out of the way, I believe today, as we have been doing for the last couple of episodes, we are going to live code some APL. We actually didn't discuss, is it going to be Rich or is it going to be Adam that's going to screen share? Who's gonna go first? Or maybe I'll just throw the problem out there, and then whoever's more excited can screen share first. So I don't actually know. I guess we could be more prepared on this podcast. It's another Perl Weekly challenge, and I remember the problem very distinctly, but I don't actually know the number. I think it was not today's, because they usually drop on Mondays, but last week's. And the problem description is you're given a string, for instance, banana, and you're asked to sum the maximum count of a vowel, like the most frequent vowel and the most frequent consonant.
Some of the count of the most frequent vowel and the most frequent consonant.
Yes. So for instance, if you have banana, that's what, 3 A's and 2 N's. So the answer would be 5. And you don't care about the B because the frequency count of the B is 1, and that's exceeded by the frequency count of the N, which is 2. And if you've got a string like ABC, the answer is just going to be 2 because you've got 1B, 1C for the consonants, 1 vowel, which is 1 plus 1 equals 2. So a rather simple problem to state. And there's a lot of utilities in the array languages for generating alphabets and whatnot. But the interesting thing is that you have to split the vowels from the consonants, right? And
need keyword vocabulary.
Yeah, we talked about that on the previous episode. So anyways, now I get to kick my feet up and throw it over to both of you. I'm not sure. Yeah.
Think a little bit.
Or we can just chat before we show code. Or we don't even need to show code. We can make this an audio-friendly episode, which I'm sure we won't.
But, purely in the brain. Yeah, I mean, the first thing that's going to my mind is key, like you said.
There's a definition question. Again, they're not so well spec'd, or at least not the way you described it. What happens if there's a word like where you have the same number of 2 different letters?
It doesn't matter because you're only caring about the count, not the value.
Yeah, but if
Okay,
there's
so
the
you
equal
wouldn't count
number of...
Yeah, if the equal numbers of
Oh, I
A's and
see.
E's, then do
You
you need
just
to
give-
count both of them, or it's just
It's just
how
the
many there
number
are
of the
one
one.
of them?
Yeah, yeah.
No,
Yeah,
like
how
think
many there
about
are
it
for
as creating a frequency count of A, E, I, O, U, and then you just do a max across those.
Ah, okay.
Yeah.
So I guess actually that comes from my, let's see, I went to week 380, and the exact problem description is you're given a string consisting of English letters. Write a script to find the vowel and consonant with maximum frequency. Return the sum of two frequencies. I'm sure it should say of those two frequencies.
And there's also a question of what is a constant, what is a consonant, and what is a vowel. But okay.
Yeah, let's just assume A, E, I, O, U are the vowels, and also it's not
Everything's
actually.
lowercase, or?
Sorry?
Just do one in lowercase.
Yeah,
because
it doesn't
it's not
state it
that
in the
much
problem, but all the examples are lowercase, so I assumed lowercase. And it's an uninteresting complication to the problem, anyways, even if it were upper and lower.
So I have a solution. I don't know if it's good or not, but it is a solution that I can show. I can build it up if you want me to.
Sounds like a plan.
Okay, so let me just arrange my window here to. Okay, this can be like this. Okay, and then I need to share my screen and see. I can find the right one.
And Asher says in the chat that he enjoyed this problem because they got to use their new favorite fork.
Okay.
Will we find our way to Asher's favorite fork? Stay tuned on episode 127 of a Raycast.
So I can build this up piece by piece. Here's the text. And what I would like to do then is, for now, let's just look at the frequencies of the letters. So we do that with key. But we don't, since we're going to look at consonants and vowels separately, we don't care which letter they are. We can just look at the frequencies themselves. We know this doesn't give us the information what they are, and this is just on the top like that. So it saves a bit of framing there. And we want the maximum of that. But again, this is just looking at all the letters. But this is what we want to do on the vowels and on the consonants separately. So we can get the vowels by taking the intersection of the text with A, E, I, O, U. And we can get the consonants by removing the vowels. So we just need to sum all of that. We can build that up as a nice over fork. So we want to have the without plus over this thing here. So plus over the max of the tally key, we could call it, with the intersection. And we're going to bind that with a right argument of A, E, I, O, U. So that means this is how the fork works. We get A, E, I, O, U as the right argument of the intersection and as the right argument of the without. And then we sum the results, but of course they're the sets of characters. So before we sum them, we apply the max of the tally top right key on it. So this is the function. And if we apply that on the text, we have that already, we get 5.
Does that work though? I think there's a bug in that.
Okay. What's the problem? I mean, there's a problem if there aren't any vowels, if there aren't any consonants.
That's not the problem.
But I suppose we're guaranteed that there will be. Right?
What about the word mommy?
Which one of them?
Doesn't matter.
Like this? So it's 3 M's and 1 of U or Y. Right? That's 4, as far as I can tell.
Okay, so I'm misunderstanding. But the bug that I thought is that you're doing without the vowels, but how do you get consonants only?
That's the intersection.
That's
no,
No,
consonants only
without
is without the
vowels.
vowels.
Here, look. Banana without vowels, BNN. Right? And intersection. So even though the symbols don't resemble each other, they're sort of complementing each other. This one leaves behind from the left argument only the ones that are in the set on the right.
Oh, yeah.
And this one leaves behind on the left argument only the ones that are not in the set on the right.
Well, now we have to have a discussion about these two glyphs, because that is very beautiful. And I did not think of that. And is this one of those things where I didn't think of it because it's not like symmetric? Because my thing, I did do the without.
Well, the set functions are fairly underutilized. Like,
Yeah,
people always forget to, yeah.
So one thing I'd like to do is like the symmetric set difference. You can write like this. And so the union, that's all of the elements contributed by both arguments. And the intersections are the elements that are in both of them. And all of them without the ones that are in both, that's the symmetric difference. That's the ones that are only in one of them, not in the other one. And here we can sort of see the symmetry. So you can even see that this shape is sort of related to these in a nice way. It's sort of a mixture of union and intersection symbols. So I mean, they are not symmetric in the sense that all three of them do not treat their left and right arguments the same. Without obviously cannot treat its left argument and right argument the same. One of them has to be the data set, another one is the ones to remove. Intersection and union could have been symmetric, but it's more versatile that they're not. So they treat the left argument as the data set, just like without does, and the right argument is the checking set, the lookup set, that where we're keeping only the ones that are also in the right, or we're keeping only the ones that are. Sorry, we're adding any that are missing. That's for the union, right? And on the intersection, we're keeping only the ones that are also on the right. So you can give this a nice symbol. What kind of solution did you have, Connor?
Well, this is, like I said at the beginning, I'm always surprised, and this is another great example. What's the best way? I'll drop it in this chat, and then you can.
What am I imagining? I'm imagining like do the full keys and then split out.
Oh wait, I just gave you the tiny apple ones.
What language? Yeah, tiny apple.
Well,
I can try to translate it, or
yeah, go ahead and translate. Oh, actually, did I?
Yeah.
Is this number 1 or number 2? It was number 1. I mean, I think did I see Madeline? Madeline's in the chat.
This is lowercase.
I mean, also too, I'll give you a arraybox link, and then you can parse it a little bit better.
Okay. Well, still don't understand how arraybox can know which valence of primitive that it needs to translate to.
I'll drop it in the
you
YouTube chat as well. I don't know, maybe Madeline can give us her solution if she wants. Although, are you going to be able to screen share this now? I'm not sure.
Not really. I mean, I can, but
then you're going to lose.
It doesn't actually translate very much. It looks like this when it's translated. Doesn't help. But let's figure out what's going on here. Oh, this is like count in or something like that.
It's histogram, yeah.
Yeah. So it's counting in itself. I mean, we can define that, but it's basically a type of key. Right?
Yeah, it's a key specialization if you want to think about it like that.
Yeah. Silas asks if we need a quad C. I don't know what the problem specification was. I did it just for lowercase, but yes, of course, if it can take any case, then you have to throw a 𝗏𝗏 on the right and of my solution. But that doesn't change much.
Yeah, I think we stated earlier in the podcast that, well, let's just assume lowercase because the casing adjustment isn't that interesting.
This doesn't even look right.
But basically, the description of what this is doing is the underbar semicolon is a pair, and quad L is lowercase alphabet. And so we're doing...
This is 𝗏𝗏 𝗏𝗏, and oops, 𝗏𝗏 𝗏𝗏.
Yeah.
And then we're binding that, right? Binding that with the without.
Yeah.
And we're doing that on the left argument. So that's...
So this is a fork.
Pair with, oh, right. Like that. With AEIOU. But then we are counting in each. Oh, okay. Oh, okay. I see what you mean. Right. So you have the vowels, the set of vowels. You have the set of letters. And then we're removing the vowels from the letters. That gives us the consonants. Now we've got the consonants and the vowels. And for each one of them, we want to remove, I believe. For each one of them, we're counting. That's what it's doing. We're counting the occurrences in the entire argument, and then we're taking the maximum of that. Okay, so I can restate this as we do with the so the first thing is to generate the list of vowels, and we can write like this: 𝗏𝗏 𝗏𝗏 AEIOU. This gives us the consonants. Right? So and then we compare this up with itself. So this is where we want comma over enclose, and we want behind here. This is not going to work quite well, but let's just do it like this for now. Does this work? What am I doing wrong here? Oh, okay, sorry, I forgot the binding thing. But why is the...
Well, you're
it's without. Yeah, 𝗏 without. There you go. Second. This is the consonants. We want that here. The problem is we need this. So it's better to do it like this. Okay, this gives us the consonants and the vowels. And now, for each of them, we want to count the occurrences of all of them in the original. So let's just call this consonants and vowels. That's easier to deal with like this. Right, so then we can say consonants and vowels, and since we don't have the frequency count thing, we'll just do an outer product with the enclosed text. Right, so this gives us this frequency table for each one of them, and then we can sum there. So if you bind this together for each of them, this gives us the sums for each one of them, and if you want the maximum, we can do that as well. I can switch this to... Oh, no, that doesn't work. Atops. Too many atops. So are we use an inner product here? No. Okay. So we want plus there. Okay. So this is the maximum occurrence of each one, right? Because there are 2 N's and 3 A's, and then we just need to sum all of that. That's essentially what's happening here. And the thing about creating the consonants and vowels, that's just a constant thing that gets bound inside the train. But it's largely the same thing as using key. Key has this sort of thing built in, and the occurrence count. What I did was I gave key an operand that just counts the occurrences, right? So instead of doing this, we can literally replace this with tally at top. Right, tech key, I think. A second. This gives us oh no, okay, we don't. Yeah, that's the problem. We want the key with vocabulary, really. Right. So here's the problem. So we need CV, and then we need to do intersection.
Prepend on.
Well, we could do intersection like this. I think
And
it'll work.
actually, does that?
There we go. And then the maximum.
I'm getting rid of.
The maximum of. What's the length area here? What? Oh, because binding. There we go. And then we can sum this. So this is essentially the same thing as the tiny APL solution, but it's obviously very similar to what I had. Because what I had was, instead of taking the intersection of the consonants and the vowels, I just took the intersection of the vowels and the set difference from the vowels. And your solution that did a set difference with the vowels from the alphabet. So you just went via the alphabet for no particular reason. You could have.
Well, the particular reason is that I didn't have the idiom of without union. Like it's I don't know, at least for me, it's a more natural step to start from like an alphabet than to make the jump that like, oh, if I do without an intersection with just the vowel set, you can back your way into just the consonants and just the vowels. Like that's not an obvious thing, or I don't know, maybe for some people.
How far do you get? I'm trying just prepend AEIOU. Then
in front of the text, you mean?
The problem is that in front of the text, and then you can say, well, the first 5 results are from the vowels, and do a segmented.
That's interesting.
Max reduce on there, but the problem.
But you don't know what the next ones are going to be.
No. The key afterwards will do it. Yeah, the key will sort that out, but you have to only subtract 1 from the first 5 results.
Okay, so if we do this, right, so we can see what they correspond to, but now we get rid of that. So that gives us all those counts. Then we do a 5 take, comma drop. That's all of them. And here we want to say -1 plus the take. We can swap those afterwards, like that. And then we want the drop of that, but then we want the max of each of them separately as well. So you want this over max.
Oh, yeah, okay.
Right?
I mean, I was looking at partitioning them, but that's.
And then we change that to a plus, and then we swap these 2 sides so that we don't need the parentheses. Just put the take on the right, like that. So this works as well. I'm not sure if I like it particularly, but
it looks like you would need comments to tell you what was going on.
Yeah, it seems really.
It's doing a lot. It's doing 1 key and far fewer set operations.
That's true, but I mean,
so
if you're talking performance, this might be very expensive too.
Prepending some stuff.
Yeah,
the copies. Yeah.
I have a question for Madeline in the chat. How do you use histogram on a string for the character counts? Or should it work naturally? But right now when I do, because that's the nice thing about Tiny Apple, is they have the primitive that like naturally your brain jumps to. Like here we have to use key, or you can use the outer product fork. But like when you have the primitive, that's like my brain and my heart are both attracted to the language that has that primitive. But
we're
then
talking about the thing just there that has the characters and the counts.
Over that. Yeah.
And so now, like, honestly, it's so beautiful. Like, it says you'd want a version of histogram that gives you a dictionary and just takes any cell. Oh, so is there no way like to change a string? Because that's the thing, a string is a character array.
You have to give it a dictionary. Okay, so here's another one we can maybe do. 1 second. Instead of, let's try it. I haven't worked this through, but maybe what we can do is we say A, E, I, O, U. Morten will not be amused here. And then sort by that.
I was wondering about that as well.
That,
you basically
that moves
end
them
up
up
the same.
front.
You still have to do the lookups after anyway.
Yeah.
Because you don't, like, at least with the keyed version, you know beforehand, well, there's going to be 5 at the front that you're interested in differentiating.
Ooh, 1 second. I have a crazy idea. It might not work out at all, but I have an interesting idea. Okay, so what happens if we go in here and say, look inside here whether the particular character is a vowel or not, and then we look at the count. Okay, so now for each one of them of the grouping 0 and 1, we want those the largest number. So I have a trick for that. So if we say -1 to the power of this, then that gives us a sign. And then we can multiply that with the tally. And now all we need to do is add the largest and the smallest. But flipping the smallest one is going to be negative. So we want to add its magnitude, but that's the same thing as subtracting. So the largest minus the smallest gives us the what we wanted. Did anybody follow that? What just happened? So this is the whole solution. So Madeline says in the chat that it breaks if there are no consonants or vowels, but that anyway it's broken if there are no consonants or no vowels. So we don't specify what, I mean, any of these solutions are going to be bad, right? Because you're going to do a reduction, a maximum reduction over an empty vector is going to give you negative infinity. So you're bad off either way. And the key, like as soon as we reach like this, and key on an empty thing, and then we try to, right? That's not gonna work. So all of these solutions use that, and even the count in is not going to help anything. You're just going to get empty vector, and then you max over that. So I don't know if the problems specify what should happen if there aren't any. I guess all the vowels A, E, I, O, U appear with a frequency of with a count of 0. So it really should give 0, right? If there aren't any.
All right, check this. You have to predefine a result vector of 2 elements, both 0 is fine, which say the first one is the count of vowels and the second one is, oh sorry, the first one's actually the count of consonants, second one's the count of vowels. I also have to
set quadrio to 0, right?
You also have to, well, you can put a 1+ if you want to.
Okay, so we set quadrio to 0, and then we update the value here, and then there's missing the last statement, which is to sum, right?
Oh yeah, the last statement is to sum.
Plus R.
Yeah. I actually have started to grow to like this pattern of doing weird manipulation within operators, but
the functional programmers will cry in the corner.
Yeah, well, I'll drink their tears.
I mean, isn't that sort of similar to what I did up here? But mine is yours is more generally applicable. You could have multiple groups. So
yeah, and you also had to, well,
not really, because it would be awkward to find out. You have to find, is it in which group does it appear?
yeah, this one happens to come okay with 2 groups, but then so
Yes,
does
but with more groups, it'll
parity
be
is also a 2 group.
yeah. But if you had multiple different groups, then I mean, this is a lot of updating, right? You keep adding, add one. This is
That's oh yeah, well, not only per key, yeah, that's once per
no, it's not add. Okay, it's updating.
thing.
It has to do the max all the time. But the max is our scalar. It's when you say one
Right,
potato.
like this is in principle more 1 potato, 2 potato, unless like array oriented, I guess.
Yeah.
But it's something that when you learn about operators and stuff, tend to fall into a pattern initially of doing something, either doing like loads of stuff. I guess this counts as doing loads of stuff in the operand, or like getting the operand, like for example, in key, sometimes you're fighting with the fact that you get a matrix out, and either I'll often do like a split transpose to get out what do you call it, exploded inverted table,
Okay.
as opposed to indexing into each of the columns. Whereas here you don't even have to worry about that because you're just dealing with the values directly, which I kind of like.
So if I go and get key with vocabulary, how does this look? And so I guess I should show the URL so people have a chance to look at it. Does it fit? Not really. GitHub, there, blob. This will be awkward for people to see anyway. Okay, so now this takes the vocabulary on the left, and now we can take the vowels A, I, O, U, and key with vocabulary on the text. Right? This gives me the indices and for each one of them, and we just need to count each and do the max. Right? Max. So this gives us that, and then we can take the other part of the alphabet. So we say here. And this gives us the max consonants. And then we can just combine all of that. So by running key with vocabulary twice, it's maybe more expensive. I'm not even sure how much more expensive it would be in an actual good implementation. This is just a model. But the actual implementation would only look for those. It would never collect information about them. As well, it would be nice if we could detect that we just want the count, so we doesn't actually have to keep the indices. So how would this look in practice? We have to do the same sort of thing as we had before with creating the C and V. But let's just say we have the consonants and the vowels. So for each one of them, we do the key with vocabulary on the right. So, and then we do tally each and do a max, and then we sum everything. Which means, yeah. Does this one work with each one of them? Yes, because no, if they're, yeah, because this one will always give 5 elements and 21 elements, right? Because we're always looking for something. We'll just give empty list. So then this will just give all zeros, and all zeros. We can try it. So if we do it with something that is like this, it should give 3, right? And if we do something that has like this, it should give 1. So the key with vocabulary, running it twice like this, it actually works. We can also, I mean, doesn't help much. We save 2 here. It doesn't help making a test it really. It's just no, you can't do that because it's an operator. So never mind. I think this is maybe the easiest one to understand. In general, keyword vocabulary is easier to understand than the normal key because there's no function application. We're just saying, okay, what are all the indices for these elements?
Yeah, and it usually involves less faff afterwards.
Yeah.
Which just adds basically noise.
Yeah, let's add that in version 22. But it's, yeah, in dialog, definitely we want to reach for key and for this sort of thing. Oh, I mean, we don't have to. We could. Okay, so here's, okay, let's define sorting first. Yeah. Now we got a sort primitive. I want that as well. Let's just call that A for ascending, as if we had a primitive for it. Okay, so now we have the text, and we can sort it. That's banana sorted. Oh, it's my bad example. We should have an example where we have some consonants first. Okay, we can do this one for now, but really what I want to do here is I want to take the vowels. No, is that even important? Yeah.
Move them
And
first.
sort with that. Why did we?
You sorted twice. You don't need to.
Yeah, but why did I lose an N?
What's T? Banana. Indeed.
Get it?
That shouldn't matter. All that.
1, 3, 5. Those are the A's.
Gonna be an N and N.
We'll close that into T. That's fine. Okay, and the fact that
does behind not do the same?
oh duh, my bad. Stupid me. This sort function doesn't take a left
Have to use
argument.
the train one.
Yeah, we can't do that.
Okay.
It has to be. I mean, you can't even do this. I mean, it have to be sorted as like this. Yeah. There. My bad.
Really?
Oh, no. This says take the left argument if it's there, otherwise the right argument. No, we can't do that. It has to be grayed like this.
Doesn't that normally work?
Yeah. Here we go. Sorry. Forget that.
Why was it getting rid of the?
No, because think about it. It's pre-processing the left argument, so it's just sorting. It's just making the grade the vowels that are has nothing to do with the right
sort
argument.
of the left, and then use that to index into the right. Okay, yeah.
Okay, so it would be nice to have a sort primitive, but this wouldn't work for the sort by the sort order. That's very special for the grade primitive. Anyway, let's just continue. Okay, so now we sort like this. So it doesn't actually make a difference in this case because we have a vowel in banana that comes earlier. But if we write something like bikini, yeah, so you get the I's first and then the B. So then that gives us 4, as that should be the result. Okay.
You don't need 2 A's here, do you?
Yeah, you do if I want, because my idea was to put.
Oh, you sort.
Yeah, I want to sort them so that the consecutive elements are next to each other, like identical elements are next to each other. Then I wanted to group it like that, but we don't know where to split anyway. So it
Right.
doesn't
I mean, that's the
really.
problem with the whole approach. So to
Yeah.
think about splitting
Well,
sort
what we
before.
could do is we could add the alphabet, even at the end. That doesn't matter because now we're sorting. Okay. So now if we look at where they're different from each other, that's where we need to split. So we take this and split on that. That gives us our groups like this. I'm not saying it's a good solution. It's to say it's a one not using key. And then we get these counts here. This is the actual count because we injected one. And now we just need to take do the 5 take plus over max.
Yeah.
With the 5 drop. Is it good? It's long, but I'm not using key. And so at the very least I could do it like this. And I got to use the added grade, so that's something. Yeah, you following, Connor?
Not this last one. I was working on figuring out how tiny APL worked, and so I wouldn't say I zoned out.
Can we look at that one?
I refocused my attention on Tiny Apple.
Oh no, we saw. Oh no, it's a new one in the chat.
Oh yeah, well, so I just got
this whole thing.
I went
we don't
down
need to
my
do
own
the partition. Let's keep it flat. Keep it flat. Keep it flat. That's what you want to do, right? So we keep this flat here.
Huh? Are you talking to me or are you talking to Rich?
I'm both of you. Whatever. I just to myself here. 1 second. So
without an outer product.
Without outer products, of course, yeah, flat without outer products. So we do comparisons like this. We actually don't. We actually might want to put this at the. Put a 1 at the end. Here. And then we just need to find the distances between them. So we can do a where on that, and then that gives us the indices where we split over, and then we want to find the distances between them, like this, and that's the one-off counts that we had before. And we see that line. That's the same line as up here above, and then we do this, and finally we just need to do the 5 thing, take over max. The drop. Take plus
over.
There you go. So here is a solution that does not use key and does not use any nested arrays at all. It's just good old APL. I mean, old APLs didn't have the pairwise thing, but you do like 1 drop, 1 take type thing. Sorry, 1 drop, negative 1 drop, and then compare them.
Yeah, old school.
Oh, so alphabet. Oh, it's Asher speaking about that. You can do an outer product. So we've got the T here, and if we do an outer product with 𝗔𝗿𝗆𝗆𝗆𝗏, and that gives us this. But we should probably put it in the opposite side, so we get like a lot of rows like this. Oh, but then the problem is we have AEIOU union with that. So this makes sure that the first 5 rows, so the union with the alphabet like this, it's the alphabet but the vowels are first, right? So now if we if you compare that with our text, then the first 5, why is that not? Oh, we forgot the 𝗏. First 5 rows are the vowels. So that means these are the counts for everything. And now we can do our classic by now. Take plus over max drop. There we go. But of course, I mean, sure, this sort of has the key, and this is key. Right?
Yeah.
Just an inefficient one. But this one is nice because we don't need to split up into 2 groups. Wonder now whether we can, if you go back to a normal T here, if we say A, E, I, O, U and union with that, yeah, that doesn't work because we don't get duplicates anymore. Okay, so how about if we say T intersection comma with A, E, I, O, U. This just puts the vowels first. Oh, but we don't know what they are. Okay, we fix that. I wanted to get all of them in first. So if you put the right argument here, now we know all the vowels come in first. In fact, we don't need all of them. We can use all the set functions in one. How do you like that? And so the union between those. Oh, but we don't know how many we're adding. That's the problem. Okay, so this one is fine. Okay, now we know we're adding one of each of the vowels. So now when we do the key and the tally, we're doing the tally top right tag. Right, so we know that the first 5 are for the vowels, and the last 2, the one remaining ones after those 5 are for the consonants. So now when we do the 5, oh, we don't actually need to do the -1 first because we know what we do stupid all those cases before we did the max of subtracting 1. We can just subtract 1 at the end because we know we're going to get too much, right? So now we take 5 take plus over max with drop, and then we get 1 more than what we need. So all we need to do is -1 plus. But we know that. I think that one's pretty neat. Now we're only using 1 key. We're not doing anything nested. We are not doing it on a huge added text. Right? This is just a reordering. This literally just puts all the vowels first. Well, hold on. Why do we even need that? We don't. That's the same thing as we did before, right? Just concatenating this in front. Doesn't that come down to the same thing?
No, the difference of concatenating just that in front, I think, was that. Well, this is why I'm slightly wondering about. Were you supposed to subtract 1 or 2? Because the problem with prepending with just the vowels was that you only added 1 to just the vowels count. So you had to subtract one from the first 5.
Yeah, that's correct, right? For banana, this is banana T, right? So there
So
are
I thought
5.
when you were doing all the set stuff that you were doing it so that you added to both.
Yeah, but no, we're not, because
Yeah.
I'm not going to add the consonants. There's no point.
What was did we get to Ash's train? Was that what we were looking at?
It says, well, he wished he came up without G intersection. I don't understand what G is.
Just a function.
Oh, just
Is this the old stuff, the original, the
Yeah.
Well, Max
without
Max asked earlier,
over-
did we get to Ash's Fork? And then I guessed it was probably the one that Adam mentioned, the without union. But it was not. And
What is Ash's Fork?
we don't know. It looks definitely like a couple
He's
of his
vanished.
messages were eaten, and so potentially he messaged it and it's being eaten. I know we tried to do something with a GitHub discussion at one point, but no one ever used that. So
If you're still there, Ash, just ping us on.
I'll just write him
Something.
internally, because when it's a colleague, you can write to them directly. With somebody out there on the internet, how do they perform? It's sort of hard to tell how they perform because we need a large text. But I guess we can try. 1 second. Asher has just sent his solution to me as well. It is loading. Let's go back here. And so Asher sent this. Wow. Why such a long name?
That's the name of the challenge.
Oh, okay, this
isn't
is just a test. Should we say hi to the people who say hi in chat? 𝗔𝗿𝗆𝗆𝗏 and Jacob Lockwood. Okay, so this is
done it now.
okay. So he's doing the outer product. He's just implementing key here. Outer product with the alphabet, and then yeah, it's essentially the same thing as we had before. But instead of doing set functions, he's implementing the set functions.
Yeah, classic.
Right. So
Yeah.
Find the mask. Do the 2 sets. So it's really the same thing. So how do they perform? We can try. So all we need to do really is just create a giant thing. Do not print this. So this is the long text. Now we need to start defining these as we need to scroll back in the history to find all our definitions. Can we do that? Where were we? There we go. So this was where I built that. So Asher says, isn't it nice to use replicate twice without needing to work around the hybridness? Yes, it is nice. Okay, so this was the F. Doing this one. And then we had the equivalent one of the tiny apple one. That's this one. Should we say TA on this one?
Yeah, okay. And then we're going to assume the constant.
And then, yeah, because the CV only gets evaluated once, right?
Yeah,
when
yeah,
it's in tacit form. So that doesn't take any time. And then we had the key when we finally got to the solution here. So this is a tiny apple with the key variant. Like that. Hopefully they will all work out correctly. What do we call this one?
Oh, that's the.
This one is silly in this regard anyway. We should. So this is the one that's it's single key.
It's the original keyword dictionary.
Yeah,
This one, powers. What do you
yeah. This
call
is
it?
the one that.
Array-oriented
Yeah, this is the one that uses the negative numbers, right?
logic, arithmetic logic.
Yeah. Single key with negative numbers. Okay. And then there was this one, the
Assignment.
index updating one. It's r gets 0 0 quad I. Well, we should set quad IO in the beginning, right? If good order. Oh, we already said it. That's fine. None of the other
Really?
ones did really rely on it.
Mm.
And we update r with this. And then we return r plus slash r there. So
Mhm.
that's the, what do we call that? One potato, two potatoes? Potato solution.
Yeah, sure.
And then there is key with vocabulary. That's this one.
Yeah, it's gotta wrap it up again.
Yeah, but how are we going to do that so that it's efficient? This is one function. This is one function. You just need to make it a top here. What did I mess up?
Interesting. Any more to the right?
No, no, it's okay.
Oh.
All good now. Key with vocabulary. I hope I'm getting all this right. Here's the key with vocabulary.
No, no, I gotta go in 2 minutes, so
Loops over both of them.
I might have to watch the recording to see how this pans out. But you're almost there. You're almost there.
Yeah, and then we did the sorting. Oh, this is the. This is getting silly, right? This is the flat sorting thing. Ugh. What's the chance that I'm making a mistake here in all of this?
Hi.
Mm-hmm. So flat sort. And this is the, but this is still doing, yeah.
Two sorts and all that.
Yeah.
Is it worth adding the weird arithmetic one? Maybe
This
not.
one.
Go on. For completeness.
Well, what's the difference between these two?
The
This is
second
with
one
the-
you're finding indices and the
Yeah.
differences. It's the first one you were partitioning?
Flat sort
or-
indices here. This is not going to end well. I'm defining all these lines at the same time. This one is the outer product one. That's sort of silly there, but this is going to be bad because we have to do this thing over and over again, even though it's a constant. So we can fix that by saying here. Outer product. And then we have got this one, which is prepend. There's so many of them. Prepend. And then finally the SOF. Hey, it all worked.
Yeah.
Wait,
Now you have to
you
generate the
vocabulary is
runtime
only
expressions for this.
It's only counting consonants?
I was gonna say you didn't run any of these. How do we know that this worked at all? All we did
Oh,
is
well,
successfully
the
store a
runtime thing
function.
will tell me if they're different.
Well, I'll find out after the fact because I've got.
Oh, this is wrong. Yeah.
So, great to see you.
Yes,
And,
this one is bad.
Talk to you later. Bye.
Bye, Rich. I can no longer coast. I was coasting, folks. Rich and Adam were doing all the heavy lifting. I had a protein bar, and
I have to be back in the game. Okay, so we got all of these, and now we need to try them all. So let's say the function names here. We got f, which was my original one. TA was what was that about? You remember? Yeah, there was the tiny APL, tiny apple, and then there was the tiny APL with based on key. And then there was the
Single key.
SK single key with negative numbers. The one potato, two potato one. Key with vocabulary. Not number 2. That's fine. FS was the flat sort. And then we got flat sort with indices. I don't know why the syntax coloring is all broken here. And then we got outer product. And we got we got pre, which was the prepending insertion thing. And then there was finally the stuff one, which was ashes. Okay, so these are all our functions, and for each function we want to append it with long. So this gives us all the expressions that we want to run. CMPX equals CY defense. CMPX those expressions up there. It didn't actually work. What's wrong with TAK? That's this one. Domain error. That works fine. And TAK with a long one? Oh, I think I know what the problem is. The long, yeah, it's uppercase. You just need to make it lowercase. Okay, let's try this. It's running. So meanwhile, while that's running, the chat they're discussing whether you need multiple keys. Yeah, you can need keys inside keys. I've done that in like database queries, things that you want to group by and multiple times, because key is really a group by. So inside the groups, you might want a two-dimensional group by. So you want a table where in one dimension you want the department, and in one dimension you want the quarter, something like that. So can't really see the graph here. Key with vocabulary looks like it gave the wrong result. Interesting. Big differences in the performance here. We can look at that, but it doesn't really matter because the performance was so bad. And key with vocabulary might have been the one we defined wrong. That's why it's only doing, but it doesn't matter. The fastest one is the prebound one. But I mean, it's tied with the SK was single key. And the tiny apple one that you came up with, Connor, is also very fast. And then the outer product one. So the thing here is that the alphabet is very small, right? So that skews things a bit. If the alphabet was much smaller, then I think it would make a big difference. So we can try that. So if we do U is question mark 1E6 reshape 11141112. That's the number of characters in Unicode. This is the code points, and these are the characters. So here are a million Unicode characters, and then we're going to run it against Unicode characters. Oh, but this is not going to work. Of course not. We can't run it because now it's not well defined. What is a consonant and what is a vowel? Right? I can't tell you. So it will, for this particular problem, we can't really say that the vocabulary is ever big, because it's really limited to the Latin alphabet. We can extend that to various other Latin alphabets that have got a few more characters each. But even if we do like Vietnamese, it's still a fairly small number of letters in the alphabet. If you want to do all of Unicode, then I mean, what is a vowel? It's not well defined. So There's no character class for Unicode that's vowel character or consonant. It doesn't work like that. It's not a real thing anyway, because the letter Y is sometimes one, sometimes the other, and silent letters and Unicode. Yeah, but it doesn't. So the participant in the chat with the unpronounceable username, something __ minus KD80Z, says call Unicode minus very loudly and just say the vowels A, E, I, O, U. But that still makes for very skewed here, because it means one group of letters we're looking for is very small, the other one is very large, and that means that whenever any of the solutions that look up in the entire list of consonants is going to be very expensive, but the ones that look up in just in the vowel list is going to be cheaper. So we also have a request to go over the solutions on ArrayBox. Do you want to drive that, Connor?
I can, but I'm gonna just have to overlay it on the screen you're looking at, and you'll have to switch to YouTube because I can't screen share on top of screen sharing.
Don't worry about me.
Well, actually, what did I? Let's see if we just do this. Will I get back the? All right, that's the old one. Where's the one that I put in the chat more recently?
I'm watching this episode on YouTube as we speak.
All right, so what? Don't do that. Do this. I'll cover my face.
Oh yeah, that's true. You're covering
and look at that. It looks seamless. Looks professional. And so, I mean, I went on a deep dive, which is why I missed like 80% of the solutions that you and Rich were covering. Because I mean, actually, and we can bring up this one as well. See if that works. So this was my original solution, which you covered and translated. But one thing that I realized, and we might need to zoom out a little bit, is that might need to zoom out. You know what? We're gonna cover your face a little bit too, Adam. This is prime real estate here, and you're still there, just hidden a little bit. And so this histogram primitive. Let me go back here so I can monitor the chat still. I actually misunderstood what I was doing in this solution. I somehow magically stumbled into a working solution, but ultimately what I was trying to do, if we zoom back in on this, I was trying to do this. If we uncomment it. So I was trying, well, I mean, actually I wasn't trying to do this because I didn't have the insight to do the without union fork. Very beautiful. And this is a famous, not famous? Well, it only really exists in my head and maybe like one other person, because I've mentioned this like once or twice on YouTube videos or podcasts. This is what I call the sci-fi tacit pattern. You've got a psi combinator inside a phi combinator. Whoo-wee! And technically, it's a phi1 combinator because it's a dyadic fork that we're partially applying. So that's not sci-fi like SCI-FI. It's a play on that, and it's PSI-PHY, aka the two combinators. But ultimately, like when you think about this problem, you really just want to do a histogram count on the vowels that exist in your string and the consonants that exist in your string. And then you do a max reduce, you add them together, you're done. The problem is that there's no array language that has all of these primitives, which is why we're playing around with key, outer product, and then having fun and saying, what if we didn't have key, et cetera, et cetera. But really, like the simplest thing, and then also I show below here because Madeline in the chat, author of Tiny Apple, mentioned that this is coming, the quad V, aka lowercase vowels, is coming in 2027. May or may not have been a joke, nobody knows. But if we did have it, this would be even nicer. And then so we have, if you combine that with the without union, you then have your consonants and vowels. You call count And that's the thing that I'll get back to in a sec. I wasn't calling count. Count just gets you the frequency counts of your individual characters or numbers in your array. I was actually calling histogram, which is the dyadic version of that. And anyways, once you do this, you do your max, you call this 𝗟 combinator, add them together, you're good to go. I think I tried to do something like that if you skip the fact that I missed the without union pattern. I was just trying to construct a 𝗟 combinator, a sci-fi fork, where you've got the vowels on one side, the consonants on the other, and then I was trying to spell this pattern in the middle, but I could not for the life of me figure out how to get it to work. And I ended up, you can tell I'm twisting stuff around in order to do an enclose, and then I've got this what I thought was count each, but it's actually a histogram each. And I guess the difference being if we open up I guess we can do it below here. We comment this out for a sec. So if you've got, I guess, and so that's the thing is banana. It doesn't work with count because it's apparently, and Madeline mentioned this in the chat, that it is defined as inverse indices or something like that. And so yeah, that's the thing actually, Madeline. So I missed the last couple comments, but Madeline just mentioned you can actually do this with a selfie on count, which then becomes
how many
a selfie
B's
on
are there,
histogram,
how many A's are there,
and you're good to go. The problem is that if you try to inject this into the middle here, you now no longer have the correct left and right arguments. And I am not a tacit ninja enough because we have combined with we've partially applied like an argument on the right, and now we're inside the fork and we're on the right tine of the over combinator, the 𝗟 combinator. And so how
did that work? I understand how that worked because that's monadic, right? So count.
Well, this is monadic and it doesn't work. But it
doesn't actually work. But if you just put the selfie there, it's
so now it becomes histogram like we saw before. Whoops. And if we zoom out a bit, and then I guess now it becomes histogram where we're providing, I guess, the values that you want to count in order. It's like the bins of a histogram that you want to count. And so now you have or wait, I'm still doing something wrong. Ruben Berg, aka Madeline's just saying, no, just replace in the first tab. Okay, I thought I did that. If this works, well, actually, I guess we gotta.
So your code didn't run before?
What? I swear to God, maybe it's too early in the morning.
Folks. That's it. Yeah,
it's not that early in the morning, folks, though. It's 11:13. It's almost afternoon. First line of the first tab.
Which one is the first tab?
This is the first tab. Oh yeah, she's just a couple seconds behind us.
Oh, okay.
How? I don't know what I did earlier, folks, but I swear to God I tried this and it didn't work. Well, actually, I didn't swear to God. I just pretty sure I tried this.
So there's a backwards over, I think, in TinyAPL that allows you to get rid of the parentheses. Just because you can't use a top operator here because you need to parenthesize the right side.
Is that gonna work? I don't think that's gonna work.
Yeah, so we have to glue them. You have to put a top explicit a top between the max and the count in.
Oh my God, that apparently worked. Oh my God. Look at you. You're TinyAPL Pro. Tiny Apple Pro. Wow.
I mean, I came up with a few of the primitives in TinyAPL. So.
And if we do this, we can almost get the 2027 version of this.
There is no Quad V coming.
Is there no Quad V? Was that a joke?
It's confirmed in the chat. It's a joke. Of course not, because it makes no sense. You can't say those are the vowels, and that's just
it makes no sense. Do things have to make sense for them to come true?
I don't. Maybe not in TinyAPL.
And so this is, God, you know, what are we talking about, folks? This is beautiful. I can't believe, though. How did I mean...
Madeline says that the circle on the bar is her own invention of a backwards over. I mean, I've mentioned in chat, I think already a long time ago, that very often there's a simple function on the left of over and a complex function, composite function on the right. So really, it would be nice to have it the other way around. But yeah.
But yeah, this is like this is what I was after when I started solving this. But then I failed to, you know, come up with this beautiful fork here. And so then I started messing around with stuff. And then I just ended up, you know, with this abomination, thinking that, you know, I don't know, this was the best that you could do. But boy, oh boy, was I wrong, folks. And this is, you know, I was also thinking too, while you were doing that whole putting all the previous defined solutions, like we gotta vibe code a little other screen while we're working through the terminal. Whenever we have a solved solution, you just copy and paste it into like a little slot. And so like the 5 minutes that we spent going back and getting all the stuff, it was you know, there's a nice, beautiful, you know, vibe coded website where you can just drop them all in, hit a button, and hide the messiness of what we were doing there. But that's...
And it will just find all the definitions?
No, just so like you're still working in the REPL, but if you just copy and paste each time you're done, like a little snippet, just copy it and paste to like, okay, we're done with that. And then at the end you can come back and just, then we hit a button, it rolls compare X, and then it does some nice little whatever fancy animation.
Yeah, I guess I could do that.
But yeah, this is...
Yeah, this is nice. It's not, I mean, is it significantly better than the key one?
Oh, of course.
Want to put the key one next to it?
I'm a code golfer at heart. You got to understand, you know, like that's
yes, I understand.
You know, when you guys were getting, you were doing the, what did they call it, the broken keyboard exercise, where it's like, what's the best you can do without this? And I'm just like, what? That's like you're stabbing the code golfer in the heart right there. It's like, you can't take my primitives away.
What do you do if you've got a broken keyboard? It's important. It's important to know.
You just I don't know. That's the thing. Well, can I still get to every primitive? I think that's the thing, is I've got control space. As long as space isn't the broken key, I can always fuzzy find my way to the primitive.
Yeah, we got language bars and things.
I didn't actually know the name of so it's backtick O. Like I didn't know that. And even pair, like I use pair all the time, but I can never remember. It's backtick semicolon. Literally, this is every time I want to type pair, I go backtick semicolon. And I'm like, oh, that's not it. And then is it backtick comma? That's not it. And I go, oh, whatever. I'll just do it. And then, like, I swear to God, every month I learn it for like 3 days and then I forget. Because I guess, like I said, I'm not coding in these languages on a. But the thing is the broken keyboard. I've got, and even if space is gone, I can do this, and then I can just fuzzy find my way. You know, there's multiple ways to get to these primitives. Anyways, is it vastly better? I mean, define better. Is it more beautiful?
What you want to put in the? You can just type in normal in dialog APL thing, and
the normal
the equivalent thing. So you want to paste it in chat for you, or?
Oh, sure, yeah.
Or you want to? You can. I can dictate it.
Okay, what are we doing here? This is
the open paren without plus.
Wait, is this going to be a this is APL, so we're just doing
this is a dialog APL one,
okay,
but it might, yeah. But just to compare what they look like. Open paren without plus over open paren.
Without plus open paren.
No, over, yeah, open, yeah, you got that. Open paren here, and then max reduction.
I guess there's lag. That's why you're watching the YouTube stream.
I'm watching the video. Yeah.
You can just keep talking. Assume I'm doing it right, and then we'll correct it afterwards.
Tally a top right tack.
Tally top right tack. That's that one.
And then after the key, you close the paren, and then you're missing the key. Yeah.
All right, I added it.
Yeah.
And then, we're the latency here. It's messing with us.
Yeah, the intersection.
It's nice that Tiny Apple is the same for most of this stuff. The keyboard.
Yeah, exactly. So and then you finish the rest, right? After the closing the parentheses, and then 𝗔𝗿𝗏 for the vowels.
Is that...
So what you are saving one character by doing the reverse over. But other than that, there's 2 characters less by having the additional primitive of the count in.
Yeah, but this is an interesting, I guess for the last 9 minutes of this conversation, it's an interesting discussion of like, yeah, I see your point. This dialogue APL solution, so I guess maybe we can put...
You can also even it out a little bit by if you don't define it with the vowels, but you just have the actual function, right? So get rid of the outer parenthesis and the 𝗔𝗏𝗏. That saves you 2 characters over tinyapl that has to have its white moons or whatever they're called.
Right. I see. But well, yeah, we'll avoid that. But I definitely see your point. The dialogue APL isn't much worse, or in other words, the tiny apple isn't much better. But I would my affinity towards the tiny apple is that this primitive, even though I misunderstood it or misused it, I should say, I'm still going to go ahead and make the argument that if you were to measure the complexity, which is obviously a very, very subjective thing, and you could argue that just like the crescent parens and the tacit programming that exists in this, that could be the most complicated thing here. But I'm a decent tacit programmer. And so when I look at the complexity in my mind of like the topics here, for me, like this is the thing that stands out as the most complex, or I don't know if complex is the right word, but for plus or minus for some definition of the right word that I'm looking for, like I always, there's so many things going on in here, like the key, the tally, the atop, the tack, when really all I want is frequency count. That's all I want. And like you can memorize this idiom as the frequency count that you want. But like for me, having a single glyph, and I guess that's the thing, is this isn't even really frequency count. It's histogram with, the...
Oh yeah, it's 4 characters, right? That is really the difference in the length here, right? That we got tally atop right key, which I remember as a single thing. I know that is that what's called histogram, right? And you got the epsilon over dot selfie, which is histogram, right? Those are 2. In either way, you have to remember a phrase. You don't have a histogram primitive for self histogram or whatever you want to call it.
Well, so
that's
the thing
what he's doing here.
Madeline early in the chat said that this doesn't work on Unicode strings. It could, but I think I don't know. I might have missed. I might have missed part of the conversation. But if I recall correctly, like if we go over here, destroy this solution, and then we just go count on iota 4, it should just give us this. But if we go this, it's not going to work, because the way that this is defined, I think, is the inverse of interval. And we could check to see
you
if
can't
that's
use
true.
it on character.
So inverse on, or is this it? Is this how you spell it? Or indices? How do you spell indices?
No, it's just iota underbar. It's APL.
Oh, right. I'm getting my languages mixed up.
PQN.
Yeah, so it's just this, and then of course that makes sense that this doesn't work, right? But if this did work, if this did work for your
so what would it would give?
Yeah, I guess I don't know. I guess it's a little bit. And that's the thing. I've had this discussion as well with Elias, creator of Cap, that I lean, probably not even arguably, definitely, it's just a fact that I lean like past pragmatic, way far to just like I just want things to work. And so one of the things that works in Tiny Apple is that if you lowercase, or if you lowercase, if you use the max glyph or the min glyph on a string, whew, but like technically, I asked Elias if he could implement this for cap, and he looked into it and considered it, but then said it kind of breaks when you go to certain alphabets, and so like it's not a as Marshall would say, it's not a very principled approach to implementing lowercase. And so I exchanged emails back and forth with Elias. It was just a couple, but he said, I did consider it, but you kind of are doing something that's not, holistically principled if you do this. That being said, I still love this because the alternative in a lot of things, I guess in Dialog APL, it's quite nice. It's just quad C, but in, I think cap, it's like, you have to use like the system function, and then it's lower or something like that. And like, like I said, I'm a code golfer at heart, and stuff like that. Like when you can shave something down to a single character, and then it's also too, it maps,
the first, I didn't invent this. The K language, at least some of them, have the round down symbol, which is the underbar, does lowercase. It doesn't have round up, and therefore the problem doesn't exist so much. Why would you ever uppercase, right? In high frequency trading land, why would you ever uppercase? And notice the K people tend to write everything in lowercase. They never even use uppercase letters. So I extended that in like my or I took that idea into the extended Dialog APL many years ago now. And I used uppercase, lowercase, and more arithmetic. So I did things like minus would flip the case, and the sign, phonetic multiplication sign that would give you the case, tell you which, if it's uppercase or lowercase, and we give like 1 for uppercase, -1 for lowercase, and 0 for something that doesn't change case. And as Jacob is saying, absolute value of a character is uppercase and negation is swap case. Yeah, but it doesn't. That's not quite right. Actually, absolute value. There are multiple issues with this, and I looked all into this when we were creating Quad C, and I'll tell you a little bit about it here. The problem. So what Marshall complained about is they're not idempotent towards each other, right? Floor and ceiling. If you floor, then you have integers and they never change again. But if you lowercase, then you can uppercase afterwards. Never mind that there are strange things in Unicode where things are not mapping symmetrically. But even that's already a warning sign that there's a problem there. But there's actually different things. There's something called case mapping, and there's something called case folding, and they're not the same. So in most cases, you see case mapping and case folding to lowercase. So the case folding is just in two versions. There's fold to uppercase, fold to lowercase. That's actually another fold, but that's so obscure, don't worry about it. But case fold to lowercase, which is what many people think of when they say lowercase, is not the same as case. Sorry, case mapping to. I messed up. Uppercase mapping, uppercase. Lowercase mapping. Mapping to lowercase is not the same as case folding. Case folding means unifying multiple letters that signify the same thing to a single character. So just like an uppercase A is the same thing as a lowercase a, linguistically speaking, we can fold the two of them together to become a single thing, which we choose arbitrarily that the lowercase form should be the standard form. But in some alphabets, some letters have variant forms. So for like in Greek, there's a final sigma, and the final sigma is the same thing linguistically, sort of, as the normal sigma, but it only appears at the end of a word. So if you want to unify all the sigmas, you take the uppercase sigma and the lowercase sigma and the lowercase final sigma. There is no uppercase final sigma, and they all get converted into a single letter, which is the non-final lowercase sigma. Okay, but this doesn't map to floor and ceiling at all. You just can't do that. So that's one problem. Another problem is that the Cherokee alphabet was originally defined only in uppercase, and then they added a lowercase form later, and therefore the normal form that when we fold is to uppercase, not to lowercase. And then there are other oddities, like in Turkish, and I think also other Turkic languages, you got dotted I and undotted I. So in English, uppercase I has no dot, lowercase I has a dot. But in Turkish, you've got an uppercase I with a dot, and the lowercase form of that is lowercase I with a dot. And there's an uppercase I without a dot, and a lowercase form of that, which is lowercase I without a dot. And they mean completely different things. And I believe somebody even got killed over the difference between them. So the mapping isn't actually as great as you might think. It seems cool at first, but it's actually not that precise. Absolute value would be the normalization. There would be the case folding, but it still doesn't quite work. Not to mention, if you're dealing with Unicode, there are actually different types of uppercasing, lowercasing, and normalization things. Where do you allow a letter to change? Do you allow a text to change length when you change the case? And you might think like, what? How does it change? How does it change length? But that is the case. In at least traditionally in German, if you take German has a double S or a set sharp S letter that looks sort of like a Greek beta. And if you uppercase that, traditionally, it splits into two normal S's. But if you lowercase that again, you get two lowercase S's, because you cannot auto-combine. It depends on the meaning of the word, whether two uppercase S's combine into a single glyph that is a lowercase double S. And then Unicode later added an uppercase double S, and that doesn't map from the lowercase one because Unicode has a stability policy. So all the tools that uppercase, they tend to fail on that one letter because Unicode doesn't define it as being the uppercase of its corresponding lowercase form. So everything is asymmetric. There's so many issues with this. And then comes the big kicker. Let's say you want to compare some data, right? Let's say you got a name of a person and an age. And you want to do some checking to see are these two representations of the same person the same? So maybe it's spelled with uppercase and lowercase letters, and the other one's only spelled in uppercase. And when you've got these mixtures or maybe a nested form of data, often you want to normalize all the character data, but you don't want to have to walk the whole structure to find the character data. So what 𝗏𝗏 does, which you probably never see, no pun intended, is that it only touches character data. So you can actually uppercase, lowercase numeric data or references or weird objects and things, and they will just stay as they are. And if we overloaded the round up and round down primitives to touch letters as well, then you wouldn't be able to change the case of a whole structure, the character case of a whole structure of data. You would have to walk it and single out the characters and convert only those. Make sense? Or there was a long monologue here.
No, I mean, a couple people in the chat are saying that it does seem like Weewa supports the ability to do this stuff with custom fill values and whatnot. But, I mean, your long monologue does highlight the point that I understand Unicode's very complicated, but I just want nice things. And guess what?
Yeah.
A couple languages that I never use are going to fall by the wayside. If I ever have my own array language, it's going to be optimized for golfing, folks, and speed as well. But if there's some like Greek letter that doesn't have something, and it's a character that goes to multiple code points, guess what? For the Greek folks out there, I do apologize, but whenever you go to type that letter and you're using my array language that is optimized for golfing, it's gonna be a sad day. Hopefully, it's only one day out of your entire life. But I do understand that there's all these things that, it's if you really want, like I say, the Marshall principled approach, you shouldn't do those things. But I am much more in favor. Not so much in I'm not saying it makes it a language better or not, but just if I had my own ideal language, I always prefer a single, the quad V. I know it's like, of course that's a joke. Is it a joke? Sounds great to me. Ship it, like.
I mean, if you're making a golfing language, so something like Jelly, Jelly has, I believe, built-ins both for the vowels with and without Y, and like uppercase and lowercase in both cases, and like so it's got all 6 combinations of those, and the consonants with and without Y, uppercase and lowercase in both of them. Yeah, sure. For a golfing language, you want that.
Yeah.
But for practical and certainly dialect cannot become a golfing language. And for practical applications, it's very useful to do this sort of thing. And that we are, you could even say that floor and ceiling should skip character data, should skip non-numeric data, and just round things. But maybe all arithmetic functions should skip non-numbers. There's another objection to this sort of thing, and that is that the definition of your language depends on Unicode. So the language itself isn't stable. And even more sort of broad is that maybe in the future, when we have contact with aliens and things, and they've got writing systems that are completely different from ours, Unicode will be replaced with something else. Right? Today, Unicode seems so universal, but it wasn't always. There were different ways of representing things before. Yeah, and as Madeline's saying, maybe Unicode version 50 has negative code points, and you want -a to give the negated a. Yeah, who knows? Maybe we discover a new dimension, and like text in this dimension needs to be like text that progresses backwards in time, or like anti-meta text, or who knows? Like we don't know what's going to be in the future. Imagine if we had made the language design way back in time when nobody in the West that designed these things cared about other alphabets and things out there in the world. Right? And then we lock down the primitives. We can't change the meaning of the primitives. Then we don't have a language to communicate in anymore. So if we lock down the meaning of these primitives based on a limited vocabulary of characters, and later we discover we actually need more, and now we can't change things, you really have this problem, right? You've got things like Windows APIs and JavaScript that limit themselves to 65,536 characters in the character set, because it was originally thought, even by Unicode, right? It was thought that, oh, that'll be enough. We don't need more characters. And then we extended Unicode to go up to, well, not quite 4 bytes, but almost, and 1.1 million characters instead. And all of a sudden, those APIs, those languages are broken, right? If you actually try to deal with Unicode text in JavaScript, you'll see that it's plain broken. I'm sure there are other languages that I'm less familiar with that are just plain broken. And you can easily write some JavaScript that creates a string that is impossible, a string that must not exist. And then if you catenate two, or join, I guess it's called there, if you can join 2 strings that must not exist, you can all of a sudden have a valid string again. You get all kinds of nonsense comes out of this, and it's a huge pain for every application, because today Unicode is generally represented using UTF-8, at least when it's in text form. You have to do all these weird conversions to 2 bytes with surrogate pairs, and there are 2 blocks of the Unicode character set that contain characters that must never appear, because they're reserved for the surrogates that are indicators that you're relying on the legacy system. It's a huge mess. And Windows defined its API based on an old version of Unicode before it appeared to people that they needed more than that. Are we really so haughty as to say that the current Unicode with UTF-8 and the 1.1 million characters, that is the final? That's it? That's all there will ever be? And if we want an array language to last forever, to be like a legacy for the ages, should we define its primitives in terms of something as fleeting as a character encoding? I think not. So system functions, they can come and go. They have a lifespan of some decades. but primitive is there forever. So by defining 𝗏𝗏, okay, maybe Unicode will go away, replaced by something else, galactic code, and we'll replace 𝗏𝗏 with, I don't know, 𝗏𝗏𝐺, who cares, and deprecate 𝗏𝗏. But if we had defined it in terms of the arithmetic functions, then yeah, it's goner.
What? It's a
So,
goner?
yeah, the language is a goner, right?
Oh yeah.
One day in the future, contact with aliens and things, and we need like 1 billion different characters to represent all the different languages in the galaxy, right? And Unicode has, as Madeline said, Unicode has said there won't be any 18th plane, right? We're cutting it off at 1,114,112 characters. And that's it. With a stability policy, we're never going to exceed that, right? 640K is enough, folks. Go home.
I mean, the limits of your imagination are that you assume that the language and communication mechanism of these aliens is going to be representable in some kind of, written or printed language.
Yeah, we don't limit
direct
language.
Direct straight to the brain. There's no way to record it. It's just alien, human. Even calling it a brain is limited. There's just going to be some way to. The best word that we have to describe it is telepathy, but
it's think about the representing dates. The year is 1970, right? How many digits do you need to represent the year? 2, right? 70. What's going to happen in 30 years? We're not going to be around. There'll be somebody else's problem to deal with that. So now the ISO standard is we represent years with 4 digits. That'll be plenty. Don't worry. Year 10,000, not my problem. And then all the software will break in year 9,999, right?
Man, this episode is...
right. So in the chat, yeah, Jacob says human aliens will have case characters. Oh, we don't know. But Madeline is saying aliens actually have middle case as well. I mentioned it briefly before, but there are actually 3 cases in Unicode. Deal with that. There's a middle case called title case, and there are only a handful of characters that have a title case, but they actually have 3 different cases. There's uppercase, lowercase, and title case on those characters. And 𝗔𝗿𝗏𝗆's name begins with one of them.
There you go, folks. What better way to end this? Definitely we didn't run off the rails episode of ArrayCast talking about aliens and the cases.
Yeah, we are the aliens.
Yeah.
Or at least 𝗔𝗿𝗏𝗆 is. Look at the code he writes, man. The array languages that he implements. Like, gotta be alien. It's got a title case character in his name.
There you go. The things you learn on a ArrayCast. All right. Well, this has been very fun. Didn't realize when Rich left, he was the only thing holding us together,
Then we went off the rails.
Yeah.
Do you think we'll be able to do a next episode? How many bits have you reserved for the episode number?
Oh, it's fine. I think we can go. I mean, it's represented by ASCII, so.
Oh, okay.
Even if we run out of numbers, which we won't, we should be fine. I guess, yeah, maybe we should do something special for the next episode. It's not every episode you have a power of 2, and they're becoming more and more rare.
Yes.
Anyways, we will leave links in the description to the Pearl Weekly Challenge, the Dyna videos, and maybe the other stuff that we mentioned in this episode. I guess with that, we will say
Happy array
programming. And thanks everybody that participated in the chat.